Good morning, everybody. We're solving a competition problem involving the floor function. Now, y'all recall the floor function does always return an integer. It's the greatest integer function, and it's the greatest integer that returns the integer that's closest. It's the greatest integer that's less than or equal to the input. Okay, so let's do a concrete example of this. And this is a little lemma here that you can figure it out here. It makes quite a bit of sense just by appearance. But let's say we wanted to do the floor of the square root of 38, for example. Okay. We know the square root of 36 is equal to 6, right? And so you would anticipate the answer being 6. Okay, but formally that's because 6 squared is less than or equal to 38. And we'll need this formality to work the problem. Less than or equal to 7, or strictly less than 7 squared. And remember, the floor of a constant is just a constant. And that's really what this equal part of the less than or equal to symbol intimates. Okay? So let's move along. Now, so since we know that k has to be an integer, and again, I didn't write that down, but k is an integer, a positive integer, not necessarily a positive integer, I guess, but k is always going to be a member of Z also. All right. So we have to ensure that n takes on this form, and this is just some algebraic manipulation. The only n's that are allowable here would be n is equal to 10k minus 21, as this algebra shows. Okay. Now, notice that for n to be an integer, this implies that k has to be greater than or equal to 3. Okay, we'll write down k. K has to be greater than or equal to 3. And again, this statement here implies that k is an integer greater than or equal to 3. And that's straightforward enough. If k were equal to 2, this would be a negative number, and you can't take the square roots of negative numbers, right? So k has to be greater than or equal to 3. So that's already a lower bound for our k, and that would correspond to a value of 9 for n, right? So we already know one solution. Okay. Now, let's move along. We also have to have this condition prevailing. Okay. And this is just simply a direct consequence of this part of the lemma, okay, that the floor of root x equals to k if and only if n is greater than or equal to k squared. That's exactly what I've put right here. You see, n is 10k minus 21, and so this is the same thing as saying n is greater than or equal to k squared, and that comes from right here. Okay. All right, so if you go through the arithmetic here, I won't go through all the details. I completed the square, and we're interested in positive values, so we ended up getting k is less than or equal to 7. Again, this is a fairly routine complete the square product or setup where we know that our k has to be. Normally when you take plus or minus square roots, you'd have a minus sign, but again, we're not interested in that because we're looking for positive solutions. Okay, so what we know is that k is greater than or equal to 3, and that k is is less than or equal to 7. So that would be 5 total integers. So if this was a how many question, if this was a how many question, we'd be done. The answer would be 5. But we're supposed to find all of them. So it's just a matter of going through this range of k's. We know that, again, let me write it out a little more neatly. We know that k right here, 3 is less than or equal to k, less than or equal to 7, right? And that's clearly there's 5 of these k's, right? Don't fall into the trap of saying 4, but there's 5 k's. I'll just write that down. So again, if the question was how many rather than what are they, the answer is 5. Okay. So there's 5 k's. Now, so let's just go through the possibilities here. For k equals 3, I'll just write, I guess, do it here. K equals 3 gives us what? N equal to 9. If k is equal to 3, that's 30 minus 21, so n is equal to 9. Okay. Let's see, let me just, k equals 4. And you know they're going to go up by 10, so you can just, you don't have to do any more calculation, right? So this would be n equals 19. And this is actually what the problem was asking for. What are the values of n? So we have 2 of them, and then so on. K equals 5. Implies n is equal to 29. Okay, k equals 6. Gives us n equals to 39. And finally, k equals 7. Gives us n equals to 49. Okay, so those are our 5 solutions, folks. Again, these guys right here, 9, 19, 29, 39, and 49 are the solutions. And that's what it asks for. Find all positive integer solutions. So that gets the job done, folks. And thank you for viewing.